So let's talk about the ideal gas law. Now, we can look at data all day long, and if we take the pressure, the volume, and divide it by the temperature times the number of particles for one sample of gas, it will always equal a constant. Now, the letter we use for that constant is R, and we call that the ideal gas constant. Now, the value of R that's given on your cheater chart on the back is 0.0821 atmospheres times liters divided by Kelvin times mole. So you're probably asking, where did that come from? Well, standard pressure for a gas is 1 atmosphere. Standard volume of a gas is 22.4 liters, coming from our molar volume. Standard temperature is going to be 273 K, which would be 0 degrees Celsius. The standard moles, or number of particles, is 1 mole. So R is calculated by doing this formula. So if we have the standard pressure times the standard volume divided by the standard temperature times the standard number of particles, you get this lovely long answer from your calculator. But since we're all about sig figs, and most measurements are not going to be more accurate than 3 sig figs, the number generally given is 0.0821, and we have atmospheres times liters divided by Kelvin times moles. Now, if your pressure unit was different, your value of R would change. So if we took 760 mmHg, which is the mmHg equivalent of 1 atmosphere, it is standard pressure in mmHg, and we multiplied it by the 22.4 liters and divided by the number of kelvins times 1, you get a completely different number. 62.4 millimeters of mercury times liters divided by Kelvin times moles. So you have to pay attention to what unit your pressure value is in. The easiest way is to just change your pressure value to atmospheres and use the R that is given. Now, the ideal gas law is traditionally written as PV equals nRT, and it can be used only when 3 of 4 variables are known. So if you have P, V, and T but not N, or P, T, N, and not V. Now, if any of those variables, P, V, T, or N, has 2 values, a P1 and a P2, or a V1 and V2, then you have to use the combined gas law, the PVTM box. Now, this base formula, when it's written straight across, so it's very easy to manipulate. So if you divide both sides by V, you get how to solve for P. If you divide by P, both sides, you get how to solve for V. N, just move those other multipliers. T, just move those over. Now, you must use the R that is correct for the pressure unit you have. That is vitally important and will mess your math up every time if you don't remember.